Well, I'm Alberto Fernandez. I'm a lecturer and developed in University of London and also in the University of Chile, and also a PhD candidate in the ballet. So, a presentation today in, let's say, 15 minutes is going to be about one part of my PhD research, which is based on how to train or AI with cellular automata, interrogating the diffusion models for adaptive architectural design. Yeah, so firstly, just a brief introduction about CA in general. So what is cellular automata? Well, as you can see, if you know, it's an interesting a physical simulation system using cellular automatons, a model that has been developed from the 1940s approximately during the end of the Second World War. And it's based on the activation of cells in the most simple scenario with from zeros to one. These elements are working as seeds that are producing by the very end a large result of different organizations, and also are showing the idea of emergent intelligence, yeah, as a collective intelligence. One of the interesting things about CA is the potential that I'm trying to achieve in order to create things that are maybe slightly more on the limit between the traditional CA approach and the how to interpret that information with approaches like, let's say, diffusion models based on neural networks. So based from this original 1 or 2 point D approaches, including for sure the classic game of life, I'm trying to just migrate firstly from the 2D to the 3D in a proper way. Then I'm understanding how to 3D print this system, but then emerges the idea of AI in architecture as understanding that also a cellular automata is a artificial life simulation system, and with the collective intelligence embedded in the process. So in that sense, a few years ago, thanks to one digital feature workshop led by myself and other colleagues from the ballet, and we were innovating a little bit with this idea of mix cellular automatas with generative adversarial networks, and training a little bit with the capabilities at that time, AI models in order to create or optimize the design workflow. Also, capturing information, or in this case, radiation. So, but now the chapter is trying to be a little bit more ambitious in a way, with the idea of mixing in the process or in the workflow cellular automatas with diffusion models. So one of the very first steps was try to understand what exactly is a cellular automata architecture for a diffusion model using prompts. So I've been working with the standard diffusion models, the 1.5, and I'm not working with the super high resolution ones because of problems with the with let's say the capacity of my GPU. But in general, if you ask about what is a cellular, let's say as a word, this is what we are actually getting, because these images were in a way part of the training process, and are also part of or are coming from the result from this this training process that happened before. And the same thing with adding the idea of automata. This is what is actually giving, or that's the thing that we are getting from the process. And if we are adding architecture, it's becoming slightly more orthogonal, is adding a different level of resolution, but understanding that, okay, I'm migrating from something really, let's say, more organical to something by far more rational. If I'm adding more words, constraining the generation. Also, if we reinterpret this with modular, the situation is changing a little bit more, as you can see, with more kind of axonometric approach. And this has been just developed just because the model has been trained in that way. So let's understand a little bit how this works and how it's possible to interfere or trying to crack the process. So as the system has been design this way, one of the key parts is the clip, which is based on the concepts that are associated with each image during the noisy process. So in that sense, okay, we can also understand with for instance that it's possible to condition the results if we are adding or we information in between. Yeah. So that if that information in between is coming firstly with the idea of how to add detail or how to, let's say, create a condition that actually is going to expand the dimension of our let's say models. So the workflow is working in this way. Yeah. So firstly, I'm creating my custom automatas from processing, using processing, this traditional this coding platform, and working with asynchronous CAs. Then I'm interrogating these images or getting information through machine vision. Then I'm training finally a new LoRa a new LoRa for basically getting my new custom models that are going to expand the stable diffusion ones. And finally, let's create new ones based from the process that I described before. So as you can see, okay, let's see if it's working well. These are or the CAs that I started to use, pretty different in between all of them. So as you can see, one behaves in a more let's say rectangular way, another one in a more concentrated way, the other one more in a linear way, and the other one more like in a way cross way. So that's the first part. Then the next one is about the database generation from these CAs. So I'm selecting around, I don't know if you can hear me. Yep. I'm selecting the images from this sequence for all the sequences that I'm actually presenting here. And after that, the most one of the important things are actually is going to happen. Let's interrogate. So basically how it works, using this the UD14 models, actually interrogating image by image about what AI can see from these patterns, and then using this workflow. And basically the results are really interesting. You usually were, if you were really boring in a way, no humans, grayscale and monochrome, few others with non-humans, but like a window or with some simple backgrounds and things like that, or with few figures, comics or grayscale or simple backgrounds again, and non-humans for sure. But still life is something that emerged also as a possible let's say similarity for the machine. Then the same thing is happening with this other collection with the idea of solos or silhouettes and so on and so on, but nothing related with cellular, nothing related with automata, and nothing related with architecture. So, but I'm using these descriptions as a base for the next step, which is the training. Because with the training, what I'm actually developing is something pretty simple, which is, okay, using the previous concept as a part of the clip connection. Also, I'm adding the idea of cellular and automata and architecture in addition to these other descriptions. So then after few hours of training, I'm getting these 4 safe tensor models that I'm actually linking with Stable Diffusion and using the Conf UI interface. And let's start with playing with this. And then with the first attempt, it was really successful in a way because I just asked for a cellular automata using one of the models that I actually trained and before. And the result was kind of hybrid, but in a good way. It's not behaving as it was before in terms of how the diffusion model understood originally what is or what was an accelerometer automata. So now I'm going to share the results according to the each, let's say, training trained database. So the ones that were linked with this set of images, let's say based on this pattern, actually the results were like this. We were like actually pretty interesting, and actually entering a little bit more about in terms of detail. It were basically like that with super integrated and patterns with a lot of interpretations in different scales, as you can see, with a mix between being organic but also understanding the idea of coming from the database, reinterpreting lines in a more orthogonal approach, using black and white mainly, instead of this colorful reinterpretation about cells, let's say, and also adding a higher level of detail for an image which is really small. It's like 512 by 512 only, showing us also this idea of motion and self-organization inside, and so on and so on. So as you can see, different ways of organizing black and whites, yeah, in a organic but also artificial way. So this is the first set of images, let's say, emerging from this process. Then, as you can see, this is the last one. It's really interesting because it's a transition between black and white, and this image based on a CA database actually is dealing with this transition using geometrical concepts that are coming from this pseudo artificial system. Then I started to use this other one, which actually generated this this set of possible results when I'm asking with this prompts. As you can see, there is also an idea of organization, but also with colors, which is something fascinating when I'm adding the idea of architecture. And also individually, they are behaving like that, a kind of more massive, let's say, manifestation, or in an isolated way in shapes of subdividing four elements in a dialogue. The same thing with this one, and also with these other patterns that are actually were emerging. Also, these patterns of kind of really condensed growing, and also cells like these ones or these other ones. Then it was the turn for this one. This one is really fascinating from my perspective because the results were like this. So with a kind of a dialogue between colors that are actually emerging, but just one color, which is particularly red or a red gamma, playing with the gray scales and black and whites. And as you can see, in a way, reinterprets the idea of cells, but with this linear growing process that is actually coming from this original pattern or this behavior. And then individually, the results were even more, from my perspective, really fascinating because are hybrids, which is one of the targets that I wanted to achieve with this process. So in one way, you can read the organicity, you can read these organic micro organizations, but then suddenly the artificial lines are actually emerging from each of these patterns. Again, the same thing, the same logic, and so on and so on, with even more and more resolution inside. Yeah, also in few of them are actually emerging the idea of an additional core that actually enrich the result. Then this one is really actually fascinating because it looks like a landscape in a way, yeah, with some topography and being cut by these regular patterns that are actually, in a way, mimicking the idea of subdivision. And then the last one is this one, which behave really different in a way, because here you can see the results were actually really successful from my perspective, because you can actually read these horizontal patterns plus few structures that are emerging, just connecting in a vertical way and generating patterns that are in a way mimicking a kind of hybrid architectural manifestation in that way, or also with some more individual examples like the ones that you can actually see. So the idea of banding, let's say, or the concept of banding, which is coming from the original database, emerged constantly in each of these possible solutions. Yeah. As you know, if it can run this basically asking and asking and asking, and I'm going to get different results constantly. Yeah. So also the idea of banding with the verticality, in a way showing an idea of subdivisions or incremental subdivision, reaching finally a kind of a noise, also is really a phenomenon that is coming from the original CAs, but in a way we're using the diffusion model. Actually, the diffusion model enrich a little bit more this concept in even more like unplanned way, but also coherent, really coherent, including these diagonals that are actually connecting the horizontal bands with the vertical ones. And then when the crossing process is really high, the resolution is actually lost, which is also part of the possibilities. Well, one of the important things is related with what is going to happen next. Yeah, because in a way, this ongoing process has been developed using 512 by 512 grid only. Yeah. So the idea of interrogation is something that is giving us the chance to generate more complex possible solutions. It depends also with it depends on or is connected with the question about how to interrogate models, how to interrogate images, and then how to get information from them. As I prove here, the CA or it's not something that exists on this kind of diffusion models. So you should prepare a database, you should train a model, and finally it's going to respond in a let's say in a better way, in a way that basically is kind of useful for our approach as a designers, and it's something that is really interesting as an outcome. Then the role of diffusion model for sure is something that we need to understand in a way, in a complementary approach, working together with the rule-based systems that are coming from the CA. Yeah. So in a way, we are closing the gap between the way computational development and also the idea of how to create architecture in a generative way, and also this approach of using AI trained models with CA patterns expands the possibilities for creating innovative and or scalable architectural designs. As I prove here, the mixture between these two approaches actually enrich the level of detail in a way that we cannot achieve easily just using one or other way of design using AI. And also the process when I'm interrogating, I'm getting these concepts that are used for the clip for the clip, and also then later for the prompting process, are actually also enriching in an unplanned way the training process. And then finally, I think the idea of combining two techniques that were not combined before produce something is intricate, but with a true potential of being a possible tool in the near future overall, if we think about how to translate or how to reinterpret these images in on proper 3D using, let's say, the pub models or other approaches that are actually giving us the chance of getting deepness and spatiality at the very end. Well, some references, and for sure, thank you very much.